My name is Manilu Mercado, and this would be my entry for the third exam, practical exam for the logic circuits and switching theory. So I already have my equations right here. So the first thing that I would do is I would add the devices that I would need. So first thing, I would need a DC source, a button, a resistor, some flip-flops, NAND gates with a NAND gate with 3 inputs. Okay, and then some NOT, and then some OR gates and AND gates. So I would be able to know that based on my equation. So upon looking at my equation right here, I realized that I would need two kinds of AND gates and two kinds of OR gates. So for my OR gates, I would need the dual and quad OR gates. For the AND gates, I would need the triple and quad AND gates. Okay, so quad OR gate, dual OR gate, quad AND gate, and triple AND gate. And then I would also need the 7 segment display cathode. So for me, I would use the green one. And then okay, everything's set. So now I'm gonna start arranging my schematic diagram. I would start with the source, and then a button. We're just gonna use one button for this one, and then one resistor. Okay, and then some flip-flops. For this one, I'm gonna be using 4 flip-flops. And then the AND gate. And then I would need some inverters or the NOT. I'm sorry. I'm gonna use NOT. So as you can see, I'm just using 3 knots right here because based on my equations, I don't have any knot for the letter A, so I'm not gonna use any knot for that. And then I'm just gonna connect the wirings first before I create the 4-bit decoder so that it would be easier to understand. Let me just rearrange this first. Okay, so first thing I'm gonna do, I'm gonna connect the negative source and then the button to the ground. And then the power side of the source to the resistor, and then the resistor to the button, and then the connection of from the connection of the resistor and the power side of the source to all of the J and K inputs of the flip-flops. and then the connection from the resistor to the button to the clock of the first flip-flop. And then from the Q output of every flip-flop to the clock of to the flip-flop beside it. And then for the last flip-flops output, I'm gonna connect that to the second input of the NAND gate. And then for the first input of the NAND gate, I'm gonna connect that to the second flip-flops output. And then for the third input of the NAND gate, I'm just gonna get that from the connection of the resistor and the button and then the clock of the first flip-flop. Okay, it's gonna look like that. And then for the output of the NAND gate, I'm just gonna connect that to all of the reset of the flip-flops. Okay, so now we just have to remember that these flip-flops are the opposite of the input. So instead of ABCD, these are actually DCBA. So to avoid confusion, we're still gonna put the knots into the proper inputs like ABCD. So I just have to like cross the wirings, but we just have to be careful with that. For us to be able to connect the inverter to the flip-flop, we just have to connect the inverter from the output of the flip-flop. Again, remember it's the opposite, so it should be like that. And for the letter A, I would just connect that later on because I would still have to create the 4-bit decoder. So for now, I'm just gonna label them first to avoid confusion again. Okay. Okay, so now I'm gonna create the 4-bit decoder, but for this part, I'm just gonna time lapse this to make the video shorter. So I actually made a mistake for the first input of the NAND gate, so I mistakenly put it into the first output of the flip-flop. Let me just redraw that. So it should actually be at the second flip-flop's output. So let me just correct that. It should be here. Oh no, here. Because this is the second output. Here. I mean the second flip-flop's output. Okay, so I made a lot of mistakes with regards to the wirings. I misplaced some of them, but I was able to correct it, and now let's see if it's gonna work this time. Okay, so now that the number 9 is displaying as a steady number, and let me try to check if it would go back to 0, and if it would go back to 0, it's actually already correct. Okay, well it did. So that is my entry for this practical exam. Thank you.